Hey everyone, this is Karthik. In this video, I'll be trying out Leetcode Weekly Contest 226. If you want more such videos in which I try to attempt Leetcode contest, then make sure that you tell me in the comments, like the video and subscribe to the channel. And let us get started with the virtual contest 226. So the first problem has maximum number of balls in a box. You're working in a ball factory where you have n balls numbered from low limit to high limit. And an infinite number of boxes. Okay, sorry about this. Let me just open Epic Pen. Yep, cool. Also, I'll open Sublime. Yeah. So working ball factor will win balls number from low limit to high limit. Okay. So there are exactly n balls and n is up to 10 power 5. And an infinite number of boxes numbered from 1 to infinity. The job at the factory is to put each ball in a box with a number equal to the sum of the digit of the ball's number. Okay. So if the ball is 2, 321, then you put it in the sixth box. Okay. Return the number of balls in the box with the most balls. Okay, that looks simple. What I can do is I can just iterate over all the balls, starting from low limit to high limit. And for every ball, what I'll do is I'll find out the sum of digits of that particular ball. So sum equal to sum of digits of this particular x. And I will put this ball in the box with this given sum, right? So let me have a hash map that would correspond to my boxes. So this map would be like box to balls. Okay. So this map would tell that box number I has how many balls. Okay. So I would say box 2 balls at this particular sum has one more ball now, right? And I need to keep track what is the maximum number of balls in a given box. So let's say max balls. Initially, I initialize it to 0. And whenever you see that a given box has more balls than the current max balls, then you update max balls. So let's say that the box 2 balls in this particular box is now greater than the maximum number of balls. Then I can update max balls, right? And I can finally return this. Let me run this code. Oops, I forgot some of digits. Actually, this should be a private method, I guess, but in a Leetcode contest, I don't really care. So let me submit this now. Actually, I should have tried it. Okay, it got accepted. Cool. Now I'll go to the next problem. There's an integer array numbers that consists of n unique elements. Okay, but you've forgotten it, of course. However, you do remember every pair of adjacent elements and numbers. Okay. You do remember every pair of adjacent elements. Okay, cool. You're given an 2D integer array adjacent pairs of size n minus 1 where adjacent pair at I is ui minus vi indicates that elements ui and vi are adjacent in numbers. Okay, so I've been told that okay 5 and 7 were actually adjacent in the array, but where they were I don't remember. But I know that okay these two people are adjacent to each other. It's guaranteed that every adjacent pair of elements nums I and nums I plus 1 will exist. Okay, this does not look very hard to be honest. The pairs can appear in any order. Return the original array nums. If there are multiple solutions, return any one of them. Okay, so if 2 1, that means in the original array 2 and 1 were together somewhere, right? This is what they're trying to say. Yeah, this means that 2 and 1 were together, like 2 comes first and then 1, either as this or this. Okay, so in my original array either I had 2 1 or I had 1 2. One of these is true. Then it says 3 and 4, so that means in my original array I had 3 4 or 4 3, one of these. Similarly 3 2 is also there, so in my original array either I had 2 3 or 3 2. Okay, and they say that 1 2 3 4 obeys all these properties because yeah 2 and 1 are adjacent, 3 and 4 are adjacent, and 3 2 are also adjacent. Okay, that kind of makes a lot of sense to me. So let's try to build some conclusions first. There is a element u. Let's think about some u. Also, are all elements distinct? to remember every pair of unique elements. Yeah. All the elements are unique. That makes my problem a tad easier, I would say. So if I see a u comma some guy, and then I can see another u comma something, but there can be at most two people who are adjacent to a given element in an array, right? So if you have a u at a certain position, then there can be one adjacent guy to the left and one adjacent guy to the right. Yep. So at most two of these rules can be for you, and for the people who have exactly one rule, one adjacent element, that is going to be a left extreme or right extreme, right? So for example, one appears only in one of these rules, right? So that means one is either your left extreme or your right extreme. Similarly, 4 appears only in one of these examples. So it's easy to find out the left and right extreme. Which of these is the left or right? That is a different question, but it's easy to find out what is the left extreme and what is the right extreme. Maybe you can just assume one of them to be the extreme, right? So let's say I find 4 appears only once, so I can assume that 4 is my left extreme. Let's just assume. Then obviously 3 comes here, and then 3 and 2. So obviously 2 comes here because 3 was obvious because 4 is here, and 2 adjacent to the adjacent of 4 should be 3. But there is no element that could be the left of 4 because I am assuming that 4 is the left extreme. So 3 has to come here. By the same reasoning, 2 has to come here, and by the same reasoning, 1 has to come here. So that makes a lot of sense to me. I guess I can just find out what are the people who appear only once in the rule. I just need to find out one such guy who appears only in one of the rules, and from there onwards, everything is simple. That's what I'm guessing. Okay, so I'll just code this up. We'll see what happens. They can be negative numbers. That doesn't matter to be honest. Let's see how we can do this. So I'll just go through all these adjacent pairs. Mm, okay. How many times did a number give? How many times did a given number appear? Let me store that. So num frequency mapping. I have this vector p, and I'll be like, okay, numfreq at p dot first plus plus, and numfreq at p dot second plus plus. Now I can find out one of the guys who appeared only once, and that's going to be my left extreme. From there onwards, my thing, the ruling should be simple, very simple. Okay, but let's say I've decided that okay, x is going to be my left extreme. Now who is the guy that comes here? That is the one guy who was adjacent to x, right? So I need to think what guy comes here. And similarly, because I need to have the entire vector, so I can probably have an adjacency list as well. Let's just have this here. Let me say uh, vector int adj list, and I'll be like, okay, adj list for this particular number. How many numbers are there? In fact, it should be an unordered map of int comma vector int. So it's basically saying that adj list at x is the vector of people who are adjacent to x. That's what it means. Okay. And what I'll do is, so p dot second has to be adjacent to p dot first. So adj at p dot first dot pushback adj at p dot second. And by similar logic, I think I might get a segmentation fault here, but I'll think about that later. I might not, so I'll think about it later. That's just language specifics. Okay, so this thing is ready. Now I'll traverse this entire thing to find out who is the guy who appeared only once. So left extreme for every auto pair belonging to the num frequency mapping. If p dot first equals to 1, then this is your left extreme guy now. Then you have your left extreme equals to, well, let me just call it left, current left. Okay, then your current left equal to p dot first And I can probably break in here and say, okay, break. Now I have my curl left, right? I'll just keep adding these curl lefts to the answer and keep finding the next curl left. And I also need to remember what are the people who have already been put into my answer vector. So unordered map, or unordered set in fact, used up, and I'll go like this. Uh, while answer.size, while I've not added all the people into this answer vector, keep running this loop. While answer.size is less than equal to number of elements that I have, so integer n equals to adjacent pairs.size, I think +1. Yeah, I guess so. So while this is less than equal to n, the number of elements I want to add to the answer vector, keep doing this, and you'll be like, okay, used dot insert the left guy, the curl left, and then add this to the answer as well. So answer dot push back curl left. Next up is that you find out what is the next curl left. So for that you iterate all the people who are adjacent to curl left. Okay, so I will iterate like this. So for every integer x that was adjacent to curl left, if x has not yet been used, if used dot find x is equals to used dot end, that means it has not yet been added into the use vector, then this is the guy that is going to be the next left. Then you will say that curl left changes to x, and you can break out of the loop now. That makes sense to me. This loop can keep running. After this I'll have my answer vector. Let me just run this code and we'll get to know how many errors I made. No member named first in std vector int, std allocator int. I said for every auto p from belonging to adjacent pairs. I was expecting, what am I expecting? I'm expecting to go over the two vectors one by one, right? That is what I'm expecting. Maybe let me just use a trivial loop then. Okay, and then I'll say that my vector int p equals to adjacent pairs. Wait a second. P dot first is nothing, right? Okay, okay. Oh, got it. Sorry. Fx So here what I should do is p at 0 because it's a vector. This will be at 1. This will be p at 0. And this will be p at 1. Let me try to run the code now. It says 1 1 1 1 1, which is pretty bad. Use dot insert answer dot pushback curl left. Now for every integer x that belongs to adj list of 1, you will say if use dot find at x is not equal to use at end, then you update curl left equal to x. Maybe there's some mistake in adj list. I guess this loop isn't running at all. So for debugging purposes, I'll do this. Let me say cout p0. So 213432. This is right. But what I'm guessing is that this loop never ran. So adj list at p0 dot pushback p1. This should actually work, right? Let me see if this loop runs at all or not. Is not equal to use dot end. Is equal to use dot end. I'm sorry. My bad. 1, 2, 3, 4. Let me submit this. Wrong answer. The answer is 1 for minus 2 minus 4. Oh, my answer is wrong. And it's expected was minus 2, 4, 1. Let me check why. So I have the rules 4 minus 2, 1 4, and minus 3 1. Okay. Then my code would run and it would say that okay, the person who appeared only once were minus 2 and minus 3. So let's say that my code found out that the left extreme should be minus 2. Cool. That's okay. That's no problem. So my code found out that okay, the left extreme should be chosen as minus 2 and it actually printed 1. Why did it choose 1 instead of choosing minus 2? Let me check my implementation here. So I would go like this. If p dot first equal to 1, p dot first equal to 1. Okay, I am sorry again. It should be p dot second. The frequency of this guy is 1. Then the guy would be p dot first. Let me run it again. We'll see what happens. It's saying minus 3, 1, 4, minus 2. That's right. I guess that would be right. Yeah, let me submit this code now. And it got accepted. Let's try the next one. Given a zero indexed array of positive integers candies count, your candies counted I represents the number of candies of the ith type you have. You're also given a 2D array of queries where queries are type equal to favorite type, favorite day, daily cap. Okay. Okay. Oh, finally I get it. You need to answer for a given query, right? That for 0 to 2 it is true. For 4 to 4 it is false. Okay, now it makes more sense. So it's that majorly I'm trying to do this, that will I be able to eat a candy of type 0 on day 2 given that I do not eat more than 2 candies at a given day. Now it makes more sense to me. So I can probably start off like this. Okay, since I have 7 candies of type 0, I could eat 1 candy on day 0, then 1 candy on day 1, then 1 candy on day 2, and my goal is accomplished. After that, how I eat doesn't actually matter. Whereas in this particular case, I need to eat 4 candies. I need to eat 2 candies of type 4. No, wait. On day 2, I would like to eat, I would like to eat at least 1 candy of type 4. And that might not be possible with a daily capacity of 4. Why is that so? Because if you eat 4 candies of type 0 on day 1, then you are left with 3 candies of type the next type. Majorly you would not be able to eat all these candies till the day 2, so you will lose. Now it makes more sense to me. Can we do it more efficiently? Like obviously you could simulate it. All we're trying to do is that by the particular, let's say that I'm trying to answer for this. Can I eat the candy of type X? I would like to eat 1 candy of type X on day Y. Given that maximum candies I can eat on a day is Z. This is my daily capacity. I would like to eat at least 1 candy of type X on day Y. That means that uh, before this day Y comes, in the first Y minus day 1 days, in the first Y minus 1 days, in fact, since it's 0 based, so I can think about it as in the first Y days. Okay, so before this, as many days appear, in those days, I should be able to eat all the candies of type 1, 0, 1, 2, 3, so on till type X minus 1. These all must get eaten up before this particular day, right? Only then will I get access to this candy. Or most of them should get eaten up except for a few other, like at max, Z minus 1 candies could remain of other types on day Y. because then I could eat z minus 1 candies of other type along with one candy of the xth type. Kind of makes sense to me. I'll probably start off with the coding part now, and we'll discuss later. I will need prefix sums for sure. Okay, I have the prefix sums. Now to answer a given query, let's see what you can do. So I'll say solve for a given query. We'll pass in the number of the day, the prefixes. Okay, let me pass in the prefix vector because that would give me crucial information for answering a query. I will pass in that. Okay, for every query, for query starting from 0, query less than query's dot size. Solve should return me a boolean. I can say okay, vector bool result, push that to results. Solve prefix q. I'm passing the prefix for sure. We pass in queries at q dot sorry, not dot, at 0. This is the crucial information I need to pass in. I can return results. Let's try to implement this function. Now. What is your what is the favorite chocolate or candy, whatever it is? What is the day on which you would like to eat that candy, at least one of that candy? And what is the max you can eat on days, so capacity? These are the things I'm passing in. Now, let's see that since you want to eat this number or this particular chocolate, right? Then in the first 4 days from 0 till day minus 1, you would like to either eat all the chocolates of type from type 0 till 5 minus 1. Either you eat all of them. So best would be to eat all. Best eat uh, or max eat. Like what are the maximum chocolates you are allowed to eat till that day, right? Mm, See, this is type 0. Yeah. So this is type 0 and I have some X chocolates of this type, X0 type chocolates. This type 1, I have some X1 chocolates of this type, so on till some ith type, and I have Xi type chocolates of this type or candies. Now I'm thinking about I plus 1th chocolate. I would like to eat at least one chocolate of the I plus 1th time on a particular day, DAY, right? Then how can I do that? First of all is that at least I should eat, the at least I should eat is till this particular day, the at least I should eat, let's find that out. At least eat. You should at least eat this many chocolates. Okay. And what is that at least? You should be able to eat all of these prefix at I, except that you can like you may not eat a few of them. Like if only cap minus 1 chocolates among these are left, then you can on the next day on the desired day, you can eat all those cap minus one chocolates of other type along with one chocolate of the type you want, right? So prefix at fav minus one, eat all of them, or at best leave out these many chocolates. That would be okay, right? So either eat all of the chocolates of smaller types or at most leave out cap minus one chocolates. Hmm. Okay, this is the least you should eat or max eat. What is the maximum that you should eat? Now, what is the maximum that you should eat? You can eat all of these, of course, and of the next type, can eat. You should maintain at least one chocolate, right, of the next type on that particular day. So the maximum you can eat before that day is eat all the chocolates till this chocolate, but leave out one. You should leave one chocolate of that type for the desired day, otherwise you lose, right? So this is the at least that you should eat, the least you can eat, and the max that you can eat. Now, I know that the lowest I can go and the maximum that I can go when it comes to eating chocolate till that particular, like starting from day zero till day minus one day before this day. Okay. Now, what is the correct lower bound? A correct lower bound would be day minus one. You can eat at least these. You will have to at least eat these many chocolates because every day you need to eat one chocolate. So if day equal to two, then on day zero and one you need to eat at least one chocolate. You need to eat that, right? And integer upper, the max you can go up is going to be you eat the maximum capacity on every day. Hmm. Also, all these should be long longs. And now, if these values intersect at any point, then I'm good. These two ranges, the least you can eat and the max you can eat, and the lower and upper, which are correct. If any of these values coincide, if there is any one value, lower and upper are all those values that I'm happy with. At least eat and max eat are all those values that I can actually achieve. If any values are common, then I'm good. So if at least eat is less than equal to see, if the ranges are disjoint, then what happens is that your max seat, either your max seat is less than lower, or see, max seat is less than lower, then this is here and that is there. Otherwise, your upper is less than at least seat. In that case, return a 0. That means you cannot actually achieve the result you wanted, otherwise return a 1. I'll try this code out, and then we'll see how many errors I made. Runtime error, nice. Addition of unsigned offset to this, overflow to this. It looks like an overflow, of course. Prefix at fav minus 1. Addition of unsigned offset to this. Let's not push this. So this solve function is giving me the error. That's the thing now. For sure, the solve function is the one causing the error. If I go up, then I see that okay, I've used prefix at fav minus 1. What if fav equal to 0? Ah, okay. So if I equals to 0, fav equal to 0, in that case, use 0, otherwise use this value. Similarly, I guess now it should run. Okay, that was dumb of me. No worries. We're getting answer true, false, true. Yep. And false, true, true, false, false. False, true, true, false, false. Yep. Let me submit. Took me a long time to code this up, and okay, finally it got accepted. We can move to final. Palindrome partitioning is a common problem, isn't it? Given a string S, return true if it is possible to split the string S into three non-empty palindromic substrings. Okay, three non-empty palindromic substrings. So A, B, C, B, A, B, C, B, and DD. So DD is obviously a palindrome. I can probably break it here. BCB is a palindrome and A is a palindrome. Okay, so answer came out to be true. Okay, okay, makes sense. What I like the straightforward thing that comes to my mind is that I'll think about the ith and jth, right? And I'll see whether this string substring from I to j is to from s to ij is a palindrome or not. Okay, then I'll try out all the possible breakings, right? Starting from s0 to si minus 1, I will find out whether this is a palindrome or not. And if it is a palindrome, my problem reduces down to breaking the substring starting from I till n. Basically, I'm thinking about this now. Also, let's take one based indexing. Right. If this was a palindrome, then my problem reduced down into taking this string and seeing if I can decompose it into two palindromes or not. And overall, if I come up with a DP, it would look something like this. I am thinking about the substring starting from the ith position till the nth position, and I would like to break it down into j number of palindromic substrings. My final answer, and this is going to be either true or false. Can I do it? Can I take this substring starting from ith till the nth and break it down into j substrings that are all palindromes? It's either going to be a true or false, and my final answer would basically be that can I take the substring starting from 1 till n, that is the entire string, and break it down into three substrings that are all palindromes. And my transitioning would be that you try to break it at every point wherever you find the first palindrome, and then recur for the remaining and break it into one less number of palindromes, the remaining string. So thinking about the complexity, it would be n into this, there are n states here, and overall transitioning time would be n, so it's going to be n squared. Not bad. I think that's what they would be expecting. So I would not be coding this up. Yeah, it's n square. I'll not be coding this up, but you get the idea. So hopefully we'll close this video here. If you liked it, make sure that you like, share, and subscribe. Bye.